In this video, I'd like to demonstrate the connection between NoMagic Cameo Systems Modeler and Ares Innovator PLM. For the demonstration, we built a previous car platform that will be used to create our next car platform, and we used the brake of an electric car as an example. So we'd like to carry over all the information that's already in PLM, the designs, the parts, and assemblies, and use this as a productivity for the systems engineer in their SysML tools. So we leverage PLM processes of change management, configuration control, and lifecycle management. The example we use is the brake system that contains of a rotor, a caliper, and a pad. You will see this in the whole demo. Within Ares Innovator, you have the library of parts and other business items. So let's look into the parts. We have all the different calipers, pads, and when you click down, also the rotors in our system. So all these different parts are part of the product definition. We also have on the systems engineering side the logical system elements, so more neutral product structure, and its structure itself. So if you look at the vehicle definition, we have a neutral vehicle containing the different wheel, an engine, and transmission, and going further into the structure. Also, we have system functions like brake with generator, charge battery. So those system functions we use in our definition of the vehicle. Combined between these elements, we have the so-called system model. And in this case, we have a vehicle model LX in a version 1. And let's have a look at that one. And that has relationships to the logical elements, the functional elements. So here the vehicle and its structure and the functional elements. But if we look deeper, look at the whole structure of this, we can load a diagram and see that there's a whole structure of this vehicle. So logical vehicle, a transmission, an engine, and going deeper down into the system, then in the end coming to the brake, the caliper, pad, and rotor. We also have requirements in our system. So if you look at the requirements list, for example, the brake heating here, requirement 7, and we open it up. We see that the requirements definition is telling us braking at 100 kilometers per hour shall generate less heat than 53 kilowatts at each wheel. These requirements we can break down into defined system parameters, which we can use later on during our calculation in the system modeling tool. So we took out speed and heat as parameters that can be used in the system modeling. The different parameters is also something you would like to manage. So all these parameters are also in our system and can be used in the modeling tool. Let's switch to the modeling tool. So Cameo's system modelers of NoMagic. Let's switch the project quickly. So when you start with an empty project, we have loaded the Ares profile, and we can load data from Ares Innovator to NoMagic. So if we go to Ares, import Ares model data, we can actually download or load the different elements we saw in the system structure, in the RFLP structure. So we see the model, the vehicle model LX, and we have the different elements here in our modeling tool. So the brake, the caliper, engine, the logical elements, but also the requirements we just saw within PLM, requirement 1, etc. That is linked to the different systems. Now we can start modeling, and let's create a new diagram. Let's create a diagram. We use the SysML block definition diagram, and then we can actually drag and drop the PLM elements we want to have on this diagram inside the BDD. So the functions, the logical elements, and also the requirements. We can also lay out this or display this in a, that we shall also see the relationships and dependencies, and that it makes a neat diagram. So this is reusing data from PLM, and you can see the IDs we show them here, although in real life you would not show them probably. But to see that these are really coming from PLM, we show the ID of the different objects, the different stereotypes, blocks, requirements, activities, and here the logical elements. The system engineer will use this to actually create or add to this model. So we go to a next project, to the car braking analysis project, in which already we build out the vehicle structure in a good way. So we added some more information about the transmission, wheel, brakes, etc., etc. We also created the brake system equations to be used for the calculation. So this is a typical thing that the typical task the system engineer will do. And let's look further into the analysis. To use these calculations, we need physical structures, and that's the part that comes from PLM. So if we look at the vehicle analysis, we see imported data from Eris. There is no imported data yet, but we can query Eris. There we are. So we can load a query. We've got some predefined queries here. And query Eris. And this will load the different pads and calipers and rotors that we actually have in the PLM system, and we can create these elements inside the modeling tool. So now we have a list of calipers and pads and rotors. In the modeling tool. We also created a functionality to actually generate a part variance. So the combination of these three are given by the model, and we created the different variants of the combined caliper pads and rotors so that we have a braking system, and we load them into based on these combinations and the defined system equations, the brake system equations, we can actually run through a trade-off study to see which combination will work for our requirements definition. So we start the trade-off study, and we'll actually calculate the different combinations and see if the heat will be exceeded or not. It's around 30 combinations, so that takes a little bit of time. And then we can actually see what combination fails. So all of these in the beginning, all the first 26 fail, but in the end we have 4 combinations of pads, rotors, and calipers that will actually pass the test or pass the equation, and we could actually use for our system. So now we found the 4 combinations that can be used. The system engineer will actually model on, and I'll load a next model with the parts already included into the system. So we see here the whole structure, but including, make it a bit larger, the right or the combinations of pads, calipers, and rods into this overview. And we can actually update this. So this design decision we can update into Ares Innovator. So if we go to Ares, we can commit the part data to Ares. And that will upload. I need to select the right model. That's it. So we upload. So we commit the part to Ares. There we are. Returning to Ares, we actually can go to the system model and see that the model was updated. It's a version 2 now by NoMagic Cameo. So look at the model. And the trade study was also stored inside the model. So the results of the trade study are visible within Ares Innovator and can be looked at. So that's one way of trying to find out what is the best solution for this brake. And we can then discuss through visual collaboration, saying, okay, let's us take a particular, let's do that. So let's take this combination here and highlight that, and then work with the rest of the engineering team on this design decision. In addition, also the model diagram got updated, obviously. So there are now, from the logical element, we see the different possibilities of parts we have. So MK825, etc. within this system. We can also now tell the system, if we collect this, that we select this as the preferred solution. So we select this part as a preferred solution. The preferred part is highlighted as the green one in the model. In addition, we also created a kind of report that shows the whole history of this of the vehicle model development, the new structure of this, and also the simulation results. Thank you for your attention.